Good evening, we enthusiasts. Welcome, welcome, welcome. What an evening. What a month it has been. We have had an incredible journey and we have talked about forces, the dynamics. And I have also said, may the force be with you, long time back. And after talking about forces, we are not done yet. Yes, we are not done yet. The end game is there. The end game is there, yes. So let's do some more work with me, Shreyas, your master teacher for physics at Vedantu, going live right now. How is everyone? How is my janta? How is my crowd? How are my we enthusiasts? Let me know. I'm just going to read up all the chats. Hello Riddhi, Science Priya, Siddharth, Jumna. Hello Shreya, hello Anu. Hello Poetry Bharadwaj. Hello, good evening. Hello, good evening. Yo. क्या बात है? Hello ESG. Hi Rajashri, hi Jetty. Hello everyone. Welcome aboard. And I hope you guys have also attended the drill discussion session. Guys, remember in this flash series we give you three major things. The major things, the three takeaways is these regular sessions which we conduct in the evenings, right? Then you have the drills. What are those? Assignments. It will be uploaded in the link, description link, as well as the Telegram group, and the discussion is done the very next day in a proper manner. All the points are discussed, right? So those are drill discussions. So do not forget to attend that. And after the chapter is over, in a day or two, you will also get the extracts, the summary, the concise way of putting that entire chapter into just few slides. So you'll be getting that, so you can easily use it for revision and mastering those concepts. Welcome aboard. Hi Akansha, hello Preja, hello Modern World, hello Shailul. I like your display picture. By the way, I was checking out so many comments on all the social media as well as YouTube, and I'm very thrilled to see many of you changing your display pictures to minions. That is our Pandu, our very own Pandu, and some of you girls have also put up Champa, and I also saw some of you have also put up some nicknames in your social media accounts calling yourselves as Pandus. Wow, that was so cool. Good. Hi Techno Gamers. Hello Dia. Hello Sudhuti. Welcome. Yes, that's really yeah, it's dark, I know. Hi Deepak. Thank you. Hello Ayushman. Hello Saurabh. Welcome. Yeah, so I've still not got that lighting correct. I hope it is slightly better than yesterday. I'm not sure. I'm just trying out different scenarios, guys. Because the problem is when I adjust during the day, things look very different, but in the night, things are very, very different. So it's going to take me some time to get these things right, but it's okay. So let's proceed ahead. So that is about me, and in case you have not followed me yet on Shreyas_Vedantu, please do it, because I had put up an exclusive insider video of my home studio, on Instagram story. So do not forget to check it out. I think it should be out by now, but I'll put it up on highlights very soon. So you will get all the insider news, you will get all the exclusive updates on Shreyas_Vedantu. That's my personal Instagram handle. Okay. Very good, Saurabh. You can see me properly. Akansha says it's slightly better. Hi. Okay. Great. Cool. So, in case you are new to today's session, do not forget to subscribe, and also do not forget to like the session, because that is where I get my energy from, your likes. Alright. So, let's begin today's session, and today we are going to talk about energy conservation. In yesterday's session, we have talked about work and scalar product. Today we are going to talk about energy conservation. So let's begin. So what exactly is a conservative force? So we're going to start with conservative force, and all those newcomers, please remember you have to also use your notes. Yeah, keep making notes as and when I discuss all of these things, so that you remember all the formulas and stuff like that. Okay, so keep making. Okay, so uncharted, put a comment below, I'll reply. Not on the chat box. After the lecture is over, put a comment, I will reply. In fact, all of you would have seen whatever comments you put up on my videos, no matter where you put it up, I always tend to reply to it as much as possible. So definitely put out comments. I always try and reply as much as possible. Okay, so what is this conservative force? So there are two kinds of forces, guys, and one is called as non-conservative, the second one is called as conservative force. So what is this conservative force? So let me give you an example and let's see what it is. Now imagine a Pandu, and this Pandu has two choices in his life. The two choices in his life are, one, to climb up a hill and come down over here, and the second choice is without climbing that hill, an easy path, and he can go like this. Well, we know that climbing up a hill and coming down is obviously more strenuous than just running on that flat line. I hope you agree with this. Yes, VSG conservation of momentum is not in this chapter, it's a separate chapter, it will come later on. First concentrate on energy, है ना? पहले energy की बात करते हैं. Okay, so he has two choices, but we are not interested in Pandu's work, we are interested in gravity's work. Gravity on him will act like this, and as he goes up, gravity will be acting at different angles and it will be doing different kinds of work when he goes up the hill and comes down. Similarly, if he goes like this, gravity will do different kind of work. Guys, can you think and tell me, if Pandu goes from here to here, okay, like this, along this blue line path, is the force of gravity perpendicular or not perpendicular to his displacement, this blue path? What do you think? Is the force perpendicular? So will you just concentrate on the slides? I know I look little bit dark today, in spite of being fair, what to do? Yeah. So, is the force perpendicular to the displacement? Yes or no? Yes, perpendicular. So, what will be the work done, guys? What do you think will be the work done? Will it be 0? Yes? Will it be 0? Very good. It will be 0. Now, think about it. When Pandu climbs up, gravity is down, displacement is like this. Can you check the angle between displacement and gravitational force? Force is down, displacement in this path is like this. Can you check the angle? Is it acute or obtuse? I feel it is obtuse. Check it out. I think the angle is obtuse. Can you see that? So when the angle is obtuse, what is the work done? Positive or negative? I told you yesterday. Yes, it is negative. Very good. I hope you understood this. Very good, very good. It is obtuse and it is going to be negative. Correct? So while climbing up, gravity did what work? Negative work. While coming down, displacement is like this and force is like that. What is the angle between displacement and force? I feel it is acute. And if it is acute, what is the work done? Positive or negative? Think about it. I think while coming down, what is the work done by that force? Think about it. It's positive. So while going up, negative work was done by gravity. While coming down, positive work was done by gravity. So I feel you will see that even if you end up calculating it, you will get the same answer. Negative and positive will cancel. The total work done by gravity will be 0. Yes, it will be 0. It will be 0. Now that's the interesting part. Guys, when Pandu goes from here to here via this blue path or this red path, the total work done by gravity is the same. In fact, if Pandu went crazy and instead of going like this, let's say for example, Pandu decides to go via some weird path, maybe like this. He flies, he goes like that and he comes here. Believe me, even in this path, the work done by gravity will be same. Basically, my point is, for gravity-like forces, the work done is independent of the path. What did I say? For forces like gravity, the work done is independent of the path which is taken. Does not depend at all. And these kind of forces are plenty in number. Example, electromagnetic force. Yes, electromagnetic force, that electrostatic force which is there between charges, even that behaves like gravity. If you know from your 9th and 10th standard textbooks, the force of gravity is gmm by r square and force of electrostatics is kqqq by r square. Formulas are also similar. So you will see their properties are also quite identical. So understand, electrostatic and gravity behave very similarly and they are conservative forces, and the reason why I'm saying that is because the work done is not dependent on the path. Similarly, there is one more force, elastic force or spring force. So if I extend a spring like this, I will do some work. But if I extend a spring like this and then like this and then I come back to the same point, the total work done will be the same. Doesn't matter if I extend it just like this or if I extend it this much and then bring it back here. Doesn't matter. The total work done remains the same. So spring, gravity, elastic, electrostatic, all these are examples of conservative forces, and you can use the fact that work is independent of the path. Now you will be like, sir, what is this got to do with other parts of the chapter? Guys, this will help me, yes, this will help me get the answers very quickly if that particle is doing some crazy thing like over here. Like this Pandu went crazy, he went some crazy path, and somebody asked you what is the work done by gravity on Pandu. You'll be like, oh my god, it's so complicated. Well, it's not. Gravity is conservative, so choose your own convenient path. What is the most convenient path? Obviously going like this. What is the work done in this path? 0. So the answer is 0. That's it. So this property helps us choose a convenient path by which you can make the calculations of the work very, very easy. That's the answer. Well, Prajwal, yes. Come on, join in. Okay. Achyutam, very good. Come on, join in. Okay. So, this was one example of conservative force. Now, let me talk about non-conservative force. And like you would have guessed, when the force is non-conservative, the work done will depend on the path, which is a good example of non-conservative force. So let's look at this. This is a top view of a table. There is a gift box, I don't know, maybe a Diwali gift, and you just pass it on to some person on the other side of the table. There are numerous ways of doing that. You can pass it on like this and go here, or you can go like this and go there, or you can just go like this, or you can go crazy and you can pass it on like this. Different ways. So I've just shown two such ways. The red dotted line and this green dotted line. I hope you can see that. Guys, won't friction oppose the motion? We have just studied friction. Friction will oppose the motion in this red path as well as this green path. Which path do you think, the green one or the red one, do you think friction will take away more energy? Which path do you think? Which path? Faizan, you didn't miss much. You just missed probably the first 5 minutes, now 10 minutes, but join in. Same? Anuradha, think again. Okay, VSG, Uncharted, Saurabh, Akansha, Riddhi, Jumna, Deepak, Achyut. All of you are saying red. Barney. Okay. Barney saying red or same. Okay, same. Okay. Geetanjali is saying you. What is you? I'm asking whether green is more or red is more or same. Jetty, I know it's different. If it is different, tell me which is different. Gopal says green. Shreya says red. Hanmay says red. Santosh also says red. Science Priya says red. Gopal, come on. Think. So guys, understand, in the red case, the friction will act. Yes, the friction will act for a larger distance. Imagine sliding this log and taking it here. It's going to take away so much of energy. Imagine the second situation where you take it along this path. Friction is going to oppose the motion, but it is just a small distance as compared to this one, because obviously it's the hypotenuse. So would friction do less work in the green path as compared to the red path? Think about it. Yeah. So the red path, you will have to push it. Aise karke, and then you have to push it like this. But here, just go from here to here, less work done. Obviously, you would choose green path over the red one. And somebody would be crazy if somebody went like this and went there. So, is the work independent? No, it's dependent on the path. So, it's a non-conservative force. No problem. Hota Gopal, no worries. Nobody is judging anyone here. We are all, you guys are all students, right? So, you have come here to learn. You are entitled to make mistakes over here, but not in the exam. Please keep that in mind. Okay, so which are other kind of forces? Well, I can give you many more examples, like viscous force, the air drag force, or even tension, normal. All these are good examples of non-conservative forces. Normal, friction, tension, viscous force, air resistance force, all these evil forces are non-conservative. Okay, great. Yes, viscosity, yes. You will be studying viscosity in detail later on. Okay, so that's one thing which you should know about non-conservative forces. So let me give you a difference table that will make things very clear. So observe this. Okay, so first let's talk about conservative forces. In conservative forces, the work done is independent of path. Okay, it's independent of the path. Whereas in non-conservative forces, the work done depends on path. Another pointer in this is the work done in coming back to the same point in closed path. Can you guess what will it be in closed path? It's very easy to visualize. Think of a mass taken up. Gravity will do negative work. When you again bring it back, positive work. Positive and negative will be same. So when you bring it back to the same point, understand total work done will be 0. So work done in a closed means initial and final path are the same. Destination and the initial point are the same. That's what it means. So that is the meaning of closed path is going to be 0. And in non-conservative forces, the work done in a closed path may not be 0. Okay, may not be 0. For conservative, for sure it will be 0. But in non-conservative, there will be at least, in fact, the better version of writing this is there is at least one path, or I'll say one closed path for which work done is not 0. Okay, so for conservative, no matter which path you take, you come back to the same point, work done is always 0. But for non-conservative, there will be at least you will find one path, in fact you might find more also, for which work done is not 0. Then examples: gravity, electrostatic. You'll be learning this in 12th. We'll be starting 12th standard portion in a month, don't worry. Then also, obviously, like I said, spring, elastic forces, all these are conservative. In fact, the word conservative has come from this statement only. Work done is 0. So positive and negative is same, so it is conserved. Okay, and for this one, examples will be friction, viscous forces, drag forces, normal, and obviously tension. All these are examples. I hope this is clear. Yeah. Okay. I hope, Pani, that is visible now. Okay. I hope. Why at least Achyut? Because it's possible that you might find a path for which the work done is 0, but that is probably a special case. So that's why it's important that you have to mention the word at least one closed path. Okay. Well, nuclear force is a very special force. We'll talk, we don't even have it in JEE. It's not a conservative force. Okay, so it behaves very weirdly. Let's not talk about it. Okay, Srilata, don't worry. This is the gist of the previous 10 minutes or 15 minutes. Akhil, just no worry, no problem. Thank you, Jetty. You're a diehard fan. Great to know. So let's go ahead, guys. Let's start solving some problems. And before I start solving some problems, let me tell you Many students have been asking, sir, I want personal teachers. I want my doubts to be cleared. I want more problems than the drills. I want test series nationwide. I want crash courses, and I want to prepare for KVPY, Olympiads and boards examination. So is there a way? Yes, there is a way, and that is a Vedantu Pro subscription, by which you will get a long-term batch along with everything that you can ask for, like tests, assignments, reviews, report cards, proper, and obviously teachers like me in all the subjects. Yeah, and obviously you have the option of studying in English as well as Hindi, and yes, you also get crash courses, micro courses. By the way, I'm starting a special micro course from next week. Yes, it's called as the physics numerical course for NEET as well as JEE aspirants. Yes, it's a micro course, only tough problems, it will be a part of this. So micro courses are free once you are enrolled in subscription, just like in Netflix or Amazon Prime. So all movies are free once you are in that subscription, so you don't have to worry about paying each course separately. No, so all courses are free, micro courses, once you enroll. And I'm starting this numerical course for all the 11th standard kids out there who want to ace in their JEE or NEET examination. So it's a micro course, you can search for it. I'll be putting up the details in my Instagram as well as Telegram group, don't worry. Okay, so thank you, Arant. So some of you are asking what is the price. So for the droppers, by the way, the 20% offer is going on. So if you take it for 6 months, usual price was 51,000, you will get a discount, and per day cost will be 227 rupees after discount. That's 20% discount. That's for droppers. Okay, 51,000, that's the total price, but it will come down if you work it out. After 20% off, it comes to 227. For 12th standard students, the total course fee for 6 months is 39,000 rupees. By 20% off, if you do the math, it's 173 rupees per day. That's it. That's very less. And for 11th standard students, again, the fees is 42,000 rupees for 12 months, not 6 months, 12 months. But if you slash off 20%, the price comes out to 93 rupees per day. That's quite reasonable. Yes. Alright. So I hope this is clear. And if you are interested to enroll into these courses, the link is in the description below. Use this coupon code and you can get the festival offer of 20%, flat 20% sale on this coupon code SHHPRO. Do not forget to use this coupon code. Okay? Chalo. So now let's talk about what is potential energy. Juhi, these classes are for both, but this channel actually is meant for JEE. But if you are studying for NEET also, you can come here. You are utmost welcome. All right? Okay. Now, so there is no such similarity between conservative and non-conservative force. Yes, VSG, you are right. Stored form of energy. The moment I talk about potential energy, you will think about stored energy. How many of you have watched this cartoon? And look at this coyote out here. He's storing the energy stored in the spring. He releases himself. It's converted into kinetic energy, and he gets fooled. And now he has gravitational potential energy. So stored form of energy. Now spring potential energy is called as potential energy, and it can be used for performing work, like on this poor coyote out here. And when he goes to the edge of the cliff, now he has gravitational energy. He can use that to fall down and convert it into kinetic energy. Looks like many of you have watched it. Even this archer out here who is pulling that bow, there is elastic potential energy stored in that bow, and that elastic potential energy is used for performing work, and that work is done on that arrow, and that arrow gets kinetic energy. You can see that. Alright, so you stretch it, leave it, and it goes. That's it. That is elastic potential energy. So let's see what and all can we think about potential energy. By the way, I have dedicated a special lecture tomorrow only for potential energy curves, equilibrium, maxima and minima. Yes, just for that. Okay, so but today we'll be looking at potential energy in terms of application point of view. Okay, so first is it is a stored form of energy. Okay, and this potential energy, understand, this potential energy, by the way, it has a symbol U. Sometimes some people also use P dot, E dot, that's also okay. Now, this potential energy depends on the configuration of the system. Now, when I say configuration means how it is arranged. For example, if I stretch that bow, how much I have stretched it. It does not depend on how did you arrive at that position. Let's say I stretched the bow like this and came back here, or I just stretched it till here. In both the scenarios, the potential energy stored in the bow will be the same. Or if I compress a spring like this, or if I extend and then compress, the energy stored will be the same. It does not depend on the path, it only depends on the current configuration. So if it only depends on the configuration, that means the change in the potential energy only depends on the final minus initial what? Configuration, and it is independent of the path which is taken. It does not depend. So you take a block, you put it up over here, or you take that same block and you bring it here. In both the cases, the change in the potential energy will be the same. It only depends on the final and the initial configuration. Correct? Yes. Now, Ankit, please post in the comments after the lecture. I won't be discussing all this during the lecture. Please concentrate. Very good. Now, also understand, potential energy has no meaning, but change in potential energy has meaning. You'll be like, what do you mean by this? What do you mean by this? I'll tell you, don't worry. So, potential energy is not significant, but delta P is. Don't worry, I'll come to that. And the last point, it's important to define zero potential energy configuration. It's very important to, when solving problems, okay, to solve problems, it's always important to define something called as zero potential energy. I'll explain all these pointers, do not worry. Now just imagine this remote out here is on the ground surface. I've asked this situation to many students, many times. This remote out here is on the ground, and if I ask you what is the potential energy, the answer should be, it's up to you. You define what you want it to be. It's not zero, it's not mgh, it's up to you what you want to define it. No Jumla, think about it. JEE, concentrate, impulse will be done later on, concentrate. Now, if I take it up over here, this remote, what is the potential energy? Somebody might ask. The answer is, it's up to you. It's not defined. It's not like mgh or zero. No, it's totally up to you. But if I compare this situation with this situation, which situation has more potential energy? Is this situation having the lower one or the higher one? Think about it, the lower one or the higher one? Which one? Which one? The upper one, higher one, correct. Now, if I ask you, how much more is this potential energy with respect to this? What did I ask? How much more is the potential energy as compared to this? That answer is mgh. Yeah. So, if you thought mgh is potential energy, that is wrong. mgh is the increase or the change in the potential energy. Understand that. Change, correct. So that's why I said potential energy is not significant, but change in the potential energy is. And you can always define something as zero. Meaning, you can say, okay, let's, for simplicity, define this point where the remote is zero potential energy. Now, if I take the block here, okay, now the potential energy is mgh. When I say potential energy is mgh, It is with respect to this state. With respect to this state. Understand that. So, yeah, work kinetic energy theorem was done last lecture. Yeah, we'll be seeing the relationship in a bit. Hold on, 1 second. Okay, so understand, when I say potential energy is mgh, it is with respect to that zero configuration. Are you getting it? Are you getting it, guys? What do I mean by that? So zero state needs to be defined. Similarly, if I have a spring, alright, it is not stretched right now. It has zero energy. So I have defined zero energy when the spring is not stretched. Now I increase the length of the spring, I have stretched it. Now if I say the spring has 10 joules of potential energy, what I mean is it has 10 joules more than that zero energy state. That's what I mean. Yeah. Alright? Great. Amazing. Just concentrate on, not on the video of my appearance. Please concentrate on the slides. That's what is important and what I'm saying. I know the lighting is little bit off. I'll be working on it. Alright? Great. So, also remember, when you solve problems, let's say a block falls from here to here. Okay? For example, there is a block here and it falls down like this. One person might say, here the energy is 0, here the energy is 40. Other person might disagree and he might say, no. Here the energy is 0, here the energy is minus 40. Another person might argue and say, no. This is 0, this is 20 and this is 60. Which one of them is correct? Which one of them is correct? The answer is all of them are correct, guys. All of them are correct. In fact, every person will measure the same change in potential energy, but the zero state is different for different observers. All of them are correct. So that is what you need to understand. You choose your own convenient 0 point. Alright? Very good. Not exactly on the observer. Suhas, I would better phrase it as it's dependent on what you choose to be 0. What you choose that configuration to be 0. Alright? Yes, correct. Alright. So let's go ahead and let's start solving some problems. And for that problems, we need something called as the addition of kinetic and potential energy. So what do you get if you add kinetic energy as well as potential energy? Yes. What do you get? You get it as mechanical energy. Okay. So mechanical energy is nothing but kinetic energy plus potential energy. As simple as that. As simple as that. Okay. So that's mechanical energy. Some people also use the symbol for this as E subscript MECH, E mechanical, and obviously the unit is again joules, and it's a scalar quantity. Okay, so standard things, symbol is E mech, unit is joules or ergs, and it's a scalar quantity. Right. So now you might be like, why are we talking about mechanical energy? You will see now. Look at this roller coaster ride. Look at this roller coaster ride, guys. Thank you, Faizan. Total energies, Saurabh, is different. It is sound energy plus energy loss in heat, that heat energy plus light energy. All these combined is called as total energy. So they are two different things. Kinetic and potential is mechanical together, but if you add other forms of energy, then you get something called as the total energy, chemical energy, etc., all that. I hope this is clear. So, very good. Now look at this roller coaster, and roller coaster mein, when the roller coaster starts from the top, it has lot of potential energy and it gets converted into kinetic energy, and again as it goes up, potential energy increases, kinetic energy decreases. So the roller coaster, if it starts from here, understand it will be able to reach very easily over here, but if it starts from here, then I don't think it will be able to complete that because it won't have enough energy. But you will see one more thing, when the roller coaster goes down, goes up, etc., If one goes up, other goes down, other goes up, the other goes down. The total remains constant. Mechanical energy is constant. Now, why do you think mechanical energy is constant? Is it always constant? Well, no. First of all, the energy is constant in this situation because there was no friction or no resistance forces. Yeah, there was no viscosity or air drag. Only that's why the potential and kinetic together remain constant. But the moment there are evil forces like friction, normal, tension, air drag, viscous, etc., you will see it will not remain constant. So, understand, potential plus kinetic will always add up to be a constant value only if, yeah, what is that statement? If evil forces are not doing work. What are those evil forces? Non-conservative forces. Another example of conservation of energy is the same one. There was spring energy which got converted into kinetic energy. Alright? So, again observe this. Spring energy will get converted into kinetic energy. So, this is also a very good example of conservation of mechanical energy. Yes, correct. There is no friction that I have assumed. So that's why all the energy got converted into spring. But just imagine there was bad force like friction. I don't think all the spring energy will be converted into kinetic. What will that evil force do? It will take away its own share from that spring energy and very little will be left in the form of kinetic. So evil forces like friction, viscous, etc. take away the energy and they will keep it for themselves. They are evil. They are like agents. They are like, you can say, like taxes. Okay? Okay, great. So, imagine there is a kid sliding down. We do not know. Now you'll be like, what is the use of this? I'll tell you what is the use of this. This is a slide whose curvature I don't know. And this kid starts from, let's say, rest. And by the time the kid reaches here, has some velocity. And I know that from this point to this point is height h, the mass of the kid is m. I want to know what is this velocity. Now think about it. If we have to apply Newton's laws, it would be one crazy problem. You'll be like, why sir? Because the inclination of the plane is not constant. So will acceleration be constant? Think about it. If the path is curved, what do you suggest, guys? Manju, they are different channels, so it's up to you. Hai so many things will go on, but you have to choose, and always you can have that option of watching it recorded. Yes. So will the acceleration be constant, guys? No, because angle of inclination will keep on changing. So think about it. If acceleration is not constant, am I allowed to use kinematic equations? Am I allowed to use kinematic equations? Bolo? Am I allowed? No, right? If I'm not allowed, then what do I do? Oh, integration, my God. First of all, integration words, something, people get heart attacks and, headaches and all that. So let's avoid that. Let's avoid that. How do we avoid that? Energy conservation. Oh, let's assume that the slide is smooth, guys, for simplicity. Now, if the slide is smooth, are there evil forces in this situation? Do we have evil forces? Do we have evil forces? Yes or no? No, right? No. Very good. Thank you, Juhi. Yes, yes. So, is energy conserved? So, non-conservative forces are not doing work. So, mechanical energy is basically conserved. Now, there is one thing. Okay, wait. Yeah, so what do I do next? I have to define something as zero potential. What do I define as zero potential? It's up to you. I will say this line is zero potential energy. It's up to me. It's up to you. You can take that also. So with respect to this point, what is the gravitational potential energy initially? Because think about it, mechanical energy is conserved means initial kinetic plus initial potential will be final kinetic plus final potential. So think about it, what would be the initial potential energy when the kid is over here, it will be mgh. Alright, it is mgh with respect to that. Friction is absent V. I just assumed it to be smooth. Very good. What is the initial kinetic energy? It was at rest. So 0 is equal to. So I just done it systematically, so you know how to do it. Whenever you solve problems, always start systematically. Only when you get very good confidence, that's when you can skip steps. But unless and until you get confidence, do not skip anything. Think properly. Final energy, it's just half mv square. What is final potential energy? 0, because anywhere on this line, I'm assuming it as 0. What is the best thing that will happen? M goes, and I'll be left with gh is equal to v square by 2. Therefore, v is equal to root 2 gh. Did I not get the answer without integration? Without having to worry about the inclination? Even if this slide was not like this, if it was like that, yes, even if it was like that, even then it will come down with the same speed, because the height difference is the same. It only depends on the height difference. What an interesting phenomenon. What an interesting phenomenon. Got ya? Very good. Shailu, Anu, Saurabh, Akansha, Jumna, Anuradha. Very good, very good. So, what do non-conservative forces do? They will not conserve energy, VSG. Very good, Advait, Faizan, Tanmay. Very good, very good. Guys, did I miss something? Yes, I missed something, and I missed it deliberately. I tell you what. You'll be like, sir, what did you miss? What did you miss? Please tell us. See, guys, here I mentioned non-conservative forces are not doing work. Yes. Friction was absent, so you conveniently applied energy conservation. But you forgot one thing. You forgot one thing. Isn't there a normal force acting on the kid? And isn't normal a non-conservative force? I'll be like, oh my god. So whatever we did is wrong. Normal is a non-conservative force. So how did you conserve the energy? So energy is not conserved? Is that wrong? Think about it. Think about it. Normal is changing. Okay. No. It is conserved. I'll tell you why. This normal is perpendicular to the displacement at every instant. So the work done by normal is 0. It's doing no work. It's perpendicular. Remember, f dot s cos 90 is 0. So it is not doing work. So you are safe. Sure, Gopal. Very good, Jumna. Yeah. No problem, Aishman. Yeah. So understand, just because an evil guy is present, don't get scared. Who is the evil guy? Normal, friction, viscous, etc. It should do something. Then you should be scared to apply energy conservation. So a force like normal, even if present or even if friction is there, but it doesn't do anything, no problem. You be there, tum shanti se raho, you be nice, I'll be also nice. That's how it is. Understood? Very good, very good. So once it happened, I was in a very nice camp area, and then I went for a nature's call, and those bathrooms are very scary, guys. And I went to the bathroom and I saw one nice big frog, and then I saw one nice big lizard, and then I also saw a scorpion roaming around in that toilet area. I didn't know what to do, but I had to be there. So I was like, as long as you are not doing anything to me, I'm okay. I just did my work and I came off. That's all. I mean, so same way, if the normal is there, friction is there, if it does not harm you, just be chill about it. Yeah, have you guys seen scorpions and stuff like that? Okay. Acha, Prajwal has, kya baat hai, everybody has seen. Okay, I hope you're not got bitten by a scorpion though. In village, क्या बात है? अच्छा, Jay hates it. Obviously, Jay, even I hate it. I get creeped out, but you have to do what you have to do. Oh, you saw a snake in front of him. Okay, interesting. A lot of encounters out there. Acha, okay. Somebody was like, sir, what are you talking about? Scorpions and all. I get scared by one dog. So please don't talk about scorpions. Scorpions is next level, level 100. I get scared by dogs. But guys, I don't get scared by dogs. I feel that dogs are very cute. What do you say? Don't you find dogs cute? I love dogs. Yeah, let's do a problem now. What a ride. Enjoy this ride. We are going to solve this question. Let's see. Shakasha, we saw a snake and Faizan has met a snake. Wow, cool. Okay, chalo guys, let's see how many of you can solve this problem. Should I start a timer? Yeah, let's start a timer. E-city is not a bio class. Bio class jana hai to there is biotonic channel, separate channel. Yes, this is physics, chemistry, maths. Yeah. Okay, chalo, let's see how many of you can solve this. I'll start the timer. Okay. Let's see. I'll start the timer now. 1 minute you have. Jetty, it will be interesting to see your scores first. So please concentrate now on the problem. Tiger screen. Deepak, green screen. I have heard. What is this tiger screen? Acha, 10 root 2, 10 root 10. Sorry. Ahmed, my God, you're too young for this channel. We have 9th and 10th standard and Young Wonders channel separate. Yeah, but you're welcome as long as you understand. Okay, let's see. Time is going to be up. Wow, most of you got the answer. The bell has rung. Let's see what the answer is. So the roller coaster of mass 500 kg has to reach a height of 50 meters at least. So this is 50 meters. So what is the minimum speed? So that means there must be a speed over here. So because of this word minimum, that means over here, even if the speed is approximately 0, it's okay, because anything more than 0, it will be able to cross over, and I will assume this potential energy to be 0 potential energy. So if neglecting any losses, so that's a very important word. Since neglecting any losses, that means mechanical energy is conserved, and if mechanical energy is conserved, initial kinetic plus initial potential is equal to final kinetic plus final potential. So just apply everything. Initial kinetic energy is half mv square, initial potential is 0, final kinetic energy approximately 0, and final potential energy will be mgh. So rearrange and you will get v is equal to root 2 gh. Now substitute everything. The path does not matter, remember. So 2 into 10 into height was 50. So guys, 100 into 10, that means 10 root 10 meters per second. Congratulations everyone, congratulations. Yesterday one of my first classes was on graphs. If you see the playlist, my first class was in fact on graphs. And graphs are there in many places. Whenever graphs come, I always discuss them, like area under force, displacement is work and all that. Alright? Very good. Excellent kids, excellent. I'm really proud of you. I'm really proud of V enthusiasts. So you should call yourself V enthusiasts. Yes, you should call yourself as V enthusiasts. Okay, let's go ahead to the next question. Okay, two balls having same mass are thrown from a height of 50 meters with same speed, one vertically down, another at an angle of 45 degrees as shown. What are the speeds when they reach the ground? Let's see how many of you can solve this. Let's see how many of you can solve this. Come on, I'm going to start the timer. Yesterday I just mentioned that. No, Manju, you should solve it initially when the class is going on itself, like immediately after that. Chalo, I started the timer. 1 minute. So you should keep solving, Manju. Don't wait for the end because then you will lose track. By that time, then the new chapter will start. So it's better to continue with my flow. Air drag is not there. No air drag. VSG. No, it's not difficult. Trust me, it's not difficult. Very easy. Come on, guys. Time is up. Let's have a look. Okay, so believe me, this angle has no meaning. How does it matter? Energy does not depend on that angle. So forget that there is an angle. In fact, both of them will reach the ground with the same speed. Why? Because they are dropped from the same height. They are thrown from the same height. So they had same kinetic energy. Direction does not matter. Remember, kinetic, potential, etc. are scalar quantities. So by the time they reach the ground, although they might take different angles, different paths, etc., their speeds on the ground will be same, guys. Yeah, that's the catch in this problem, and then there is nothing great about it. So, if you think what is the potential energy over here, let's say I call it zero potential energy. At this point, the balls will have a potential energy of mgh as compared to this line. So, initial potential plus initial kinetic is final potential plus final kinetic. So just use that, you'll get the answer. Therefore, mgh plus. Do I know the height? Yes. So let's put the height. So m into g is 10 into height is 50 plus half into mass m into speeds. What is the speed? 10. So 10 square is equal to final potential 0, final kinetic half mv square. Best part, m gets cancelled from everywhere. 10 into 50 is 500 plus 10 square 100 by 2 is 50 is equal to just v square by 2. 500 plus 50, 550. 550 into 2 is nothing but 1100 is equal to v square. Therefore, v is equal to root 1100 meters per second. Both will have same speeds. Yeah, 10 root 11, not 10 root 10, 10 root 11. Yeah. Very good. Yeah, sure, Tanish, if you have the right aptitude and if you are understanding, definitely, why not? Why not? Okay, so that was the question. Very interesting. So this had no meaning. JEE does these kind of tricks and they confuse people many times. Now, let's solve some questions on spring potential energy. Let me give you the formula first because then you can apply it. If you have an unstretched spring, this potential energy which an unstretched spring has, 0. This is your 0 configuration. 0 config. Remember, just for gravity, we always define those lines. That is 0 potential, this is more, this is less. So for spring, which is unstretched, we are calling that potential energy as 0. If you extend or compress, doesn't matter. It always will store energy. Compressed or an extended spring stores energy. How much energy does it store? Half k x square. What is that k? Remember that k is your spring constant. Okay, so k is nothing but the spring constant. Unit is Newton per meter. We are seeing what is K before this. X is your either extension or compression. Either of them will work. Half kx square. Chalo, remember this? Remember this? Okay, very good, very good. Yes, Jay, definitely it will be helpful because we are completing 11th and 12th syllabus both. Yeah? Okay, so let's solve a problem. And before solving a problem, observe this simulation. Block comes with some kinetic energy. This kinetic energy goes away. Spring stores that energy and gives it back to the block. Assuming no energy is lost, obviously. Kinetic energy goes, potential energy stored, potential energy goes away, gives it back in the form of kinetic. So this is a good problem of energy conservation. This is assuming there is no sound, heat, loss of friction, light, etc. produced in this problem. If there was friction, loss of energy due to collision, then the speed with which it comes back will be a little bit less than what the initial speed is. Understand? Very good, Tanish, if you are understanding. So guys, I'm keeping it simple. So I look at that. If a guy like Tanish can understand, I'm pretty sure all the 11th and 12th standard and a dropper kids should be able to understand it. Okay, so let's see how many of you can do this question. I'm starting the timer in a bit. Read the question carefully. I'll start the timer. A car running with a speed of 30 km per hour is stopped by a spring of constant 200 Newton per meter. What is the maximum compression in the spring? Come on, let's see how many of you can do this. I'll start it in 3, 2, 1, and now. Come on, do this. Okay, car's mass needs to be given. I'll just reset. Okay, car's mass also needs to be given. I'm so sorry. Yeah, you need the car's mass, I believe. What is the maximum compression? Okay, so take the mass of the car as 100 kg, guys. Okay, we'll restart the timer. Okay, 1 sec. So the car's mass is 100 kg. So just use this fact and then start solving the problem. Yes, I've given the mass. Come on guys, come on, come on, come on. Come on, come on, come on. Okay, time is running out. Okay, looks like a lot of you got stuck in the calculations. No problem guys if you got stuck in the calculations, but I hope at least the steps what you have done are correct. Okay, no issues, no issues. Sivijya, Anuradha, Jumna, Siddharth will discuss this problem now. So, what is happening in this problem? In this problem, like you can see, the car had some kinetic energy. Yeah, the spring had zero potential energy. When the spring compresses by maximum amount, there is spring potential energy, but the kinetic energy becomes zero because it has stopped completely. And conserving the energy, here is what I will do. Initial kinetic energy was half mv square, correct? Potential energy, well, potential energy was not there only. Eventually, kinetic is zero and spring is half kx square. Correct? Now just rearrange the terms. Half gets cancelled. So mv square is equal to kx square. Therefore, what will you get? X is equal to, think about it. Yes, we will come outside and root of m by k. That is the answer, but you have to substitute the values. And before you even substitute, there is one more thing you need to do, guys. This 30 kmph, we need to convert it into meters per second. So 30 into 5 divided by 18. Yes, you need to do that. So yes, you need to do that. Without that, you will not get the correct answer. So you can simplify. Maybe you can just keep it in fraction also. So 30 goes with 6. So you can call this 5, and this also goes with 6. You can make it 3. So it will become 25 by 3 meters per second. And you can substitute it over here and you can get the answer. So it will be 25 by 3, and mass is 100 and spring constant is 200. So that will give you 25 by 3 root 2 meters. That's the answer. No, 450 is not the answer. This is the answer. I hope this is fine. I hope this is fine. Okay? No worries. If you did not get it, now I hope you have understood it. Everyone fine? Shall we go ahead? We are going to go to some very good problems now. Very good problems. Let's have a look. So we'll see some questions where mechanical energy is not conserved. So when non-conservative forces are present, like I said, mechanical energy is not conserved. So what could be some examples? Look at this. A 10 kg block moving with a speed of 5 meters per second eventually stops due to friction. How much distance does it travel before it stops? Okay, so let's have a look at this problem. And for this problem, maybe some additional data needs to be given. So let's say mu is equal to 0.5 is also given to me. Block is also given. Okay, that's it. So mu is example 0.5. Okay, so now in this problem, it's very obvious that due to friction, mechanical energy is not conserved. So now what do? Think logically, you will get the answer. Initially, because it has some speed, won't it have kinetic energy? Yes. Well, potential energy is not changing, so why worry about it? So potential energy just is constant. So potential energy will not change here as well as here. This is just constant, so just forget about it. Just ignore. Okay? When it stops, what is the kinetic energy? Well, the kinetic energy is 0. If the kinetic energy became 0, why did it become 0? Because this evil guy, which is that evil guy, friction has done work in this displacement. And where will friction act? Like this. So this friction has done work on it. So that's it. I can say my kinetic energy was lost in the basically by friction. So by friction, that's all. So how much energy was lost? Half mv square. How much did friction suck away? It's the frictional force into the displacement. Okay, so just substitute the values, you will get the answer now. Half into m, you keep it as what is it? 10 into what is the velocity? It's 5. What is the frictional force? Well, it is mu into n, but normal force will be mg, right? So 10 into 10. I hope you get that. This is m and this is g. Okay, so that's mg. All right, very good. I hope everybody is understanding it. And into the displacement s. Now just do this math and you will get the answer. Yeah, that's about it. So check it out. How much are you getting? How much are you getting, guys? Are you getting it as Yeah, I know the fan sound. I will be taking care of the fan sound, etc. very soon. Yes, 2.5. Very good. 2.5 meters is the final answer. Excellent, excellent, excellent. I know extra sound is coming because of that UPS fan. I'll be taking care of it very soon. Don't worry, don't worry, don't worry. It's not the fan, it's the UPS fan. I cannot turn it off. If I turn off the UPS, the entire lighting board, everything will just go off. So that's why I cannot turn it off. I cannot turn it off. Alright? If it was the fan, I don't mind sweating for you guys. I would have turned it off long time back, guys. Trust me. Alright. So let's do the best problem now. Okay. Yeah, a block of mass m is dropped from a height onto a spring. What should be the maximum compression in the spring? Very good problem. Let's try and do this problem. A lot of people make mistakes in this problem. That's why I'm going to do this on my own. Okay, so observe. So now this block is dropped from some height. Okay, it will have gravitational energy which will convert it into kinetic, and once it touches the spring, it has some speed, so it will continue compressing the spring till it stops completely, and eventually it will stop and again it will be thrown up. But you have to just consider from here to here. That's the motion which you need to consider. So I've just shown some steps over here. The block starts, just touches the spring, and now it starts compressing till here. I hope these steps are clear. And let's try and solve this problem. It's a very, very interesting problem. Here it is at rest. Here it has some velocity. Again here it is at rest. When I say it is at rest, it has been just left at time is equal to 0. At this point it just touches the spring. That's what happens. And at this point what is happening is it has max compression. That is what is happening. Is this situation clear? No, it's not exactly at equilibrium, because at equilibrium net force must be 0. No, here the force is not 0. It's still continuing its motion. It will accelerate. Okay, so that's a different thing. Okay, now let's try to write down what kind of energies are involved. I feel gravitational energy is involved, and spring energy is also involved, and kinetic energy is also involved. Okay, so three kinds of energies: kinetic, spring, and gravitational. Now let's choose a suitable reference line. I feel, let me choose this line. Yeah, when it comes over here, okay, this line as zero potential energy line for gravity. So for gravity, I am taking that line as zero potential energy. I hope this is fine. And let's assume this distance as x, and it is already given. This is nothing but h. It's given. It's dropped from a height h from this point. So the further compression is x. Believe me. Yeah. Now, what is important to understand? Since mechanical energy is conserved, okay, now observe this very carefully. Initial kinetic plus initial potential is final kinetic plus final potential. Guys, quickly think and tell me, what is the initial kinetic energy? Bolo, what is the initial kinetic energy? Come on, can you think and tell me? Can you think and tell me? Correct, you will see now what is going to happen. Compression is done because of gravity as well as momentum, both. Very good, zero. Now, potential energy will be of two types. One is spring. Spring is not compressed only, no. So just forget that spring energy, it's zero. Plus potential energy. Believe me, the potential energy is not mgh. Yes, it is mgh plus x, because this is 0 and this height is x and this is h, so it is h plus x. That's the potential energy. A lot of people make a mistake here. They write potential energy is mgh. Keep in mind, when the block is going down, even then the potential energy is decreasing. Yes, even then the potential energy is decreasing, not just this much. you have to take into account the complete change in the potential energy. Understand that. I hope this is clear. And then this will be equal to, when it finally stops, what is the kinetic energy? 0. And what is the potential energy? Well, there are two types again. One is spring. How much is the spring energy? Half k x square, because that's what I gave you just some time back. And what is the gravitational energy when it comes here? It's 0. This is my complete equation. This is my complete equation. And now you can solve this. It's not that difficult. So it will become mgh plus mgx is equal to, there is nothing here, so it is just half kx square. Now let's shift all these guys over here and let's see what do we get. We'll get kx square by 2 minus mgx minus mgh is equal to 0. I can shift that 2 on the top, so it will become kx square minus 2mgx minus 2mgh is equal to 0. Now, the reason I wrote it like this, can you guess why did I write it like this? What is the reason? What is the reason for me to write it like this? It's not so simple to solve. Why? Because it's a, come on, can you answer it? Why did I write it like this? Jetty, if you stay with me, believe me, you will prepare like me only. Quadratic equation, correct. Yes, it's a quadratic equation, so there will be two roots. I'm going to erase the top one because I don't have any space, so please bear with me. Okay, so I'm going to erase just the top one. Okay, just to make some space. So I'll use this over here, and therefore x will be equal to minus b. You have learned quadratic equations, so 2mg, that's what I think should be there, divided by 2a, that means 2k, plus minus root of, look at what the discriminant is, b is this guy out here, b square, but the 4m square g square minus 4 into a, which is k, into c is minus 2mgh. Okay, so that's what it is. Let's simplify. I'll get 2mg plus or minus. I can take 4 common, so it will come outside the root, and I'll have m square g square minus minus becomes plus. It will become 2mghk divided by 2k. Okay, now I'm going to erase this because I'm going to need more space. Now I can cancel that 2 from everywhere, so therefore x will be mg plus minus root m square g square plus 2mghk, and this entire thing divided by k. That 2 has been cancelled off. Now should I include both the values? No, below was 2 only, I think. Just check it out. Sudhuti, okay, just check it out. Why? I got 2 values. Which value should I choose? Plus or minus? Come on guys, let me know. Should I choose plus or minus? Got it? Yes, choose the plus, because if you choose the minus value, x will be negative. X is a positive number. If x is negative, that means the spring is not compressed, it is extended. That is not correct. X has been assumed to be the compression, so you have to ignore that minus value. So it will be just plus. This is our final answer. Yes, this is a proper advanced question, by the way. Did you love it? Did you enjoy this problem? What a problem. I love this. Very good, very good. So let me tell you, this is just the trailer. I'll be taking even more problems in the micro course, which I'm going to start in another 2 weeks, to make you fully prepared for JEE, Advanced, KVPY, BET, SAT, you name it. So that micro course is about to start. It will be called as numerical solving session for JEE and NEET. Alright, so that's a micro course which I am about to start. There are many more micro courses by many more teachers for different subjects which you can freely enroll using the subscription, and you obviously get tests, assignments and other things. So the 20% off is running. Do not forget that the coupon code is SHHPRO. Link is below. Use that so that you can avail all the benefits out there. And on the Telegram link, we'll be putting up the discussion, the drill discussion, yes, on Telegram as well as in the description box. So if you do not find it in the description, most likely it will be over here. So do not forget to join the Telegram group to get the drill discussion. You'll be getting an assignment based on today's and yesterday's session. There are very good problems. Do not forget to solve it, because tomorrow morning I'll be discussing it. Yes, tomorrow morning at 12 o'clock I'll be discussing it, and again I'll be meeting you at 7 p.m. tomorrow evening. Alright? So, Chinky, the description made there is a link, Chinky. Alright? For Telegram. You can just join it. Alright. Yeah, I left minus in the formula because it does not make sense, Sudruti. Alright? So guys, do not forget to like today's video if you have enjoyed today's session, and all the newcomers out here, do not forget to subscribe for today's class and for getting all the notifications. It's very important you subscribe and like, or else YouTube won't recommend you all these videos. Alright? Thank you guys. I hope you had a great time. Stay safe, stay home. Bye bye. Signing off. This was Shreyas here, your master teacher for physics. See you very soon. Bye bye. Take care.